Most people know about giant infrastructure projects that we call particle accelerators. But what actually are they, and what have they done for us? Well, particle accelerators are devices that produce beams of fast-moving electrically charged atoms or particles. Physicists use particle accelerators because they help fundamental research on the structure of nuclei. Now, the first step in a particle accelerator is to accelerate a charged particle. Let's say we have protons as well as electrons. We can accelerate these particles using electric fields. The energy from the particles is measured in electron volts. Now, to guide these particles, we use magnetic fields, which create circular motion. And now, we have to make them interact. Physicists use head-on collisions to make them interact. Okay, but let's take a step back. What's the point of this? When particles accelerated at such fast speeds interact, it turns the energy released by both particles into new particles and helps us find out about the deepest structure of reality. This is governed by the equation E equals mc squared. Well, it's not the real particles that collide, which turn into mu particles, but the kinetic energy of the particles is literally created into mass, and thus mu particles. We are literally able to create particles out of pure energy. And now, there are two types of collisions. There's a collision where the beam collides into a target like a wall, and where two beams collide into each other, and this is a modern method. The second version uses the kinetic energy to create new particles, while the first method wastes a lot of this kinetic energy. Okay, so now we know about the really big circular particle accelerators. But did you know that we actually use them more often than these? There are giant accelerators like the CERN in Geneva, as well as the national labs in most countries. These accelerators are the ones we use in order to do fundamental research, such as work on the Standard Model as well as the Higgs boson. But there are also medical particle accelerators in cancer radiation therapy, as well as in X-ray machines. Particle accelerators are also used in industrial purposes, such as sterilization. So most particle accelerators are actually used way more often than most people think, and there are only a few giant ones. But there are issues as well, like why do governments spend so much money on the big ones? Well, we spend large amounts of money on particle accelerators because they uniquely enable both fundamental scientific discovery and the practical technological process. At the most basic level, accelerators show physicists to probe the structure of matter at extremely small scales, and to create particles that don't exist under normal conditions, which make them essential for testing and extending theories such as the Standard Model, as demonstrated by discoveries at CERN. But beyond research, the engineering challenges which are involved in building and operating these machines have consistently produced a lot of technological innovations, including advances in superconducting magnets, computing, and even in the development of the World Wide Web. Many accelerators also have direct applications in medicine and industry, such as cancer radiation therapy, medical imaging, and materials processing. So the high cost of these accelerators reflects the extreme energy, precision, and scale required to explore new physical regimes, combined with the broad scientific, technological, and economic benefits that result. So, as we can see, particle accelerators are pretty amazing, but they are also pretty complicated devices and cost a fortune. However, these accelerators have helped the world in so many ways and continue to be a point of investment and innovation. If you guys enjoyed this video, make sure to like and subscribe. Be curious like a child, the world needs more of it. Bye!